All right. So our next topic here is called series. And series takes a sequence and adds them together. Okay. Easier said than done, but that's what we're doing. And again, we can have finite series. And these are just, we're adding up a bunch of numbers. This is why we invented Excel, is because it'll do that for us. We also have infinite series. And there's a couple of these we're going to look into. For now, we're just getting used to like, what does this mean and how do we do it? So we'll probably talk about infinite more tomorrow. But finite series, that's what we're dealing here. We're just going to add up a list of numbers. That's it. Okay. So it's the notation here more than anything else. Okay, so 1 through 5, this is 2i minus 6. Okay, I don't know if our calculators can do this offhand. I suspect they can, but I don't know how to do it. But what we're going to do is we're just going to type in I equals 1, 2, 3, 4, and 5, because we are going from 1 to 5. Now, it's not obligatory that you start from 1. There are certain series that start from 0. You can start from 45. Doesn't matter. Okay, so this is the start, this is the end. They're usually going to give you a point to pick from, but there's no rule that says it has to start from 1 and go to 5. Okay, so all we're going to do here is like, well, 2 times 1 minus 6, so that's going to be 2 minus 6, which is negative 4. When we get to 2, we have 2 times 2 minus 6, that's 4 minus 6, that's negative 2. 2 times 3 minus 6, we have 6 minus 6, that's 0, that's fine. Here we have 2 times 4 minus 6, so this is going to be 8 minus 6, which is 2. And 2 times 5 minus 6, so that's going to give 10 minus 6, which is 4. And I'm pretty sure I could add this up pretty quickly, and equals 0 if I add all of this stuff up. All right, so let's start for that one. Okay, go check. Thanks. Okay, very good. All right. Now, this is a special kind of, well, we'll talk more about these kinds of series tomorrow, about what they call geometric series. Again, n is 2 to 4, so we just have 1/2 raised to the n. So we'll say n is equal to 2, 3, or 4. Okay, so that's 1/2 raised to the 1 power. 1/2 raised to the, to the 3rd power, right? This is, oh, I messed up. That's not a 2, that's a 4, because we're starting at 2. So n is 2. Okay, 3, 1/2 raised to the 3rd power is 1/8. And this is 1/2 raised to the 4th power, which is 1/16. So this is 4/16, this is 2/16, this is 1/16, so it should be 7/16, 6, 7. All right, and then we can go from there. Okay. So let's see here. Okay. So we can have alternating series as well. Okay, alternating series, changes between pluses and minuses, so that's all there is to that one. So we're just going to write this down. That's a terrible sum sign. Okay, so sum m is equal to 3 to 6, negative 1 to the m minus 1 of 3m equals, and we have to add this up. Oh, by the way, I, J, K, L, M, and N, these are all your typical counters. So when you do your sum from I, you could pick I, J, K. L is not chosen as often, M is not chosen as often, but N is chosen most of all. Okay, but there's no real like law that says you have to do these particular letters. It's just that they're the typical ones people pick. So, you know, if you're using something, if you're using X's, then people are going to get confused because like, what do you mean by X equals? be careful with I. Okay, I had hopefully I've never been this bad, but I have had a teacher that used we had an e to the I. This is an imaginary number. To the sum of I is equal to 1 to whatever it was, okay, of something else. There was some kind of a function in here. I being a counter, so this was 1, 2, 3. So this was an integer, this was a complex number, and we were using it to figure out a current. So of course it was I is equal to that as well. So we had I as the result of our function, we had I as an imaginary number, we had I as a counter. So yeah, that was my award for the worst notation ever. But you know, that's how it goes. So -1, we have m minus 1, so that's going to be 3 minus 1, that's going to be squared. And then we have 3 times 3, so that's going to be 9. That was I is equal, or m is equal to 3. M is equal to 4. Right, so we have -1, 4 minus 1 is 3, and then we have 3 times 4, so we end up with -12. Okay, m is equal to 5. I sense there's a pattern here. -1 to the 4th, and then we have 3 times 5, so that's got +15. Okay, and m is equal to 6, and that's -1 to the 5th, and 3 times 6, so that's going to be -18. Okay, so if I add all of these up, right, we have 9 minus 12 plus 15 minus 18, so we have -3, and -3 is -6. -6. Oh, it didn't like, oh, -6 is what I meant. I didn't, there we go. One down. Okay. Okay, now it's your turn to make up series. So we have our pattern, and they want to say, well, what do we make out of this? So in this case, I would say, well, how about I equals 1 to 5 of 3i? All right, so that should give me, right, that sum. And there's certain things that you can't change, right? You said it's I, being a counter and not being an imaginary number. And we're going from 1 to 5. There's more than one way to do this. Okay, if you pick like I plus 1s or something like that, I could easily get the same thing. Generally, you want to aim for like, what's the easiest way of doing it? Okay, you don't want to go out and say, well, how can I make this as difficult a summation as possible? Don't do that. -1/4 plus 1/8 minus 1/16 plus 1/32. But just because you came up with 1 doesn't mean that it's wrong, as long as it comes out to be the same thing. So let's see, this looks like 1/2 raised to the, is this an I? What is this? This is an I. And we started off with a positive 1, so let's go ahead with I plus 1. Oh no, I want to go with 1/2, and I want to go with -1, right, to the I plus 1. So we could also do this. We could say, well, I plus 1 is really -1, right, times -1 times 1/2 to the I. So this is -1, right, -1/2 to the I. That's going to be the same thing. So we could write it both different ways, write it the same way, or different ways rather, and get the same answer, and that's fine. So we could say, I wonder if they'll let me do it, -1, and then -1/2, oops, raised to the I. Oh, it gave me a chance to write that down. Beautiful. Okay. These programs have come a long way. Before, if you didn't write down like exactly the thing that they wanted, you pretty much didn't have it. Okay, I'll leave you to do this one. This one's not so bad. And the last one here, this one is clever. Okay, there is a spot The only application I know of this is differential equations, but it's an important skill to be able to deal with. Is going from I is equal to 1 to 3, 6i to the 8th. And they want to know, like, what happens? J is equal to 0, and we want to have another one, k is equal to 2. So it might be helpful to like break down. So I is 1, 2, and 3, and we have 6 times 1 to the 8th, 6 times 2 to the 8th, 6 times 3 to the 8th. So here, right, for j is equal to, right, we're going to have j is equal to 0, j is equal to 1, j is equal to 2. We pretty much want to match these terms. All right. So here we have, right, we have, how about we do, I want j is equal to 0. So how about we do, 1 plus 0 to the 8th, 1 plus 1 to the 8th, 1 plus 2 to the 8th, and I think they'll get the same thing. Okay. For 2, okay, we'll say k is equal to 2, 3, and 4. We pretty much have to do the same thing. So 6, 6, and 6. And we need about 2 minus 1. Oh, no, sorry. 3 minus 2. We have to start at 2. So 3 minus 2. 3 minus, I don't want to do that. I want to do plus. All right, so there we go. So I want to do, k is 2, 3, and 4. How do I turn it into that, right? So how about 5 minus, no, I don't want to do minus, I want to do a plus. Sorry, my neighbor is doing something, so I'm a little distracted here. Yeah, negative 1. Okay, there we go. So negative 1 plus 2 to the 8th, negative 1 plus 3 to the 8th, negative 1 plus 4 to the 8th. Okay, so one thing I do kind of want people to understand is like, okay, oh, sorry, my cat is on the keyboard. There we go. So we went from 1 to j is 0, and then what happened to my counter? I subtracted 1 from my counter. Right, from here we went from 2. I pretty much am subtracting 2 from my counter to deal with all of that, to put it, or subtracting 1 from my counter to make sure that it's consistent. Okay, so there's a little bit of a trick to kind of to see that. It'll haunt you in 2 years, but so I'm sure you'll remember. But there is a way to kind of do that. But for now, it's just look at the experiment and see what happens. So eventually we'll make a rule, but for now we're just going to just kind of wing it. Okay, so I'm going to go ahead and stop recording the entire thing now.